always wanted to my control system lecturer, Dr. Rusli bin Omar, and my dear friends. So today we are from group 1, gonna present on controllers principle. So here's my group member, Sharvina and me myself, Danish Singh and Intan or Azrina binti Jamaluddin and Fahim bin Azri. And as my topic, as introduction, we're going to talk about controllers principle as P, PI, and PD. So what is PI, PID? So P is proportional, PI is a proportional integral, and PID is a proportional integral derivative, which are the controllers are mostly commonly used in every control system principles. Control system in generalism. And as we talk about P, PI, PID, so what's the main intention of that, right? So their main intention was it detects the deviation of a system and produces a signal process, control signals that reduce the deviation at 0 and to a small value. So in manner which the automatic controller produces the control signal is called the control action, which is control system. And moreover, a closed loop systems compared to the system output with the desired input, aiming to minimize error and meet the system requirement. So as we talk about the PI, PID and P principles, we're going to learn about the transient response also. So transient response refers to how a control system reacts to during the transformation phase from one state to another state. We say like that. And their requirement was a settling time, a rise time, a overshoot, and a steady state error. So this is the requirement for the transient response to be occurred. And as we're using MATLAB, so we're going to use BEJ20503 tuner in our Simulink. Simulink is a kind of app which we can modify or design our own screen in MATLAB. So as far as we did, we're going to use our Simulink in a BEJ tuner. So BEJ tuner is easily to say that BEJ tuner allows engineers to design transient response requirements, which initially generates any controller parameter values. It means like we can set up our own values on the BEJ tuner to get a perfect transient response as we say. So P controller provides a control action proportional to the error, reducing steady state error by means of low response and overshoot. But PID controller adds an integral term to reduce steady state error and enhance the system's response, which is more advanced than PID. Then if you have a PID controller, it incorporates a derivative term to improve the stability of the graph and stiffness and responsiveness and reduce the overshoot and settling time, which give a perfect transient response compared to the other tools. So, moreover, engineers and other control system type of things can iteratively adjust the proportional integral and derivative gains using the PID tuner and observe the system's response even in real time. And PID tuner can observe the system response in real time also. Moreover, utilizing the PID tuner in a Simulink allows engineers to effectively tune like PI, PID, and PI and P controllers by ensuring the transient response requirement are met. If I say there's a requirement for PI, P, and PID controllers, right? So if they have met the requirement, they will get a good perfect transient response itself. So PID Simulink allows them by doing that. So then finally, the iterative tuning process optimizes system performance as is desired for the control objective. So here's me. Thank you.
My name is Sharvina Murugan. My tick number CE220111. Okay, so now I will be explaining about the method. So first, to do method, we have to launch the MATLAB software. And then in MATLAB software, there's an icon, which is Simulink. So we have to press the Simulink to design the system. So once we press the Simulink, we will get a few options. So we must press black model to create our system. So there'll be two systems that we'll be doing in method. First one is open loop system and second one is a closed loop system. So for the first part, I'll be doing the open loop system. So open loop system is the one in which the output signal is not fed back to the input of the system. So in this open loop system, we will require 4 components, 4 blocks that has to be added in this blank diagram. So in library browser, we can find the blocks. So first we need the source, which is step. And then we need the scope to view the graph output. And then we need the transfer function, and as well as the multiplexer. Okay, now we can arrange all of these. Okay, so before we join the arrows, we have to assign the numerator and denominator values. So for our group, we have chosen the numerator to be 1 and denominator is 1, 1, 1, 6, 11 and 6, and then apply, and then okay, and then we can start to connect the arrows. And then to connect the arrow at the upper part, we must right click the mouse and drag it to the multiplexer. And then we also must make sure the step time is 0, and then apply okay. So in order to view the graph, we can press run, and then we must press double click the scope, and then we can view the graph, the output of the step response. Okay, so next I'll be designing for closed loop system, which is also known as feedback control system, which uses the concept of open loop system as its forward part, but has one or more feedback loop between its output and also input. So for closed loop system, there's 6 blocks we need to add in this blank model. So we must open library browser, and as same as the open loop, we must add scope, and then under sources we must add stats, and then we also need PID controller, transfer function, and also multiplexer, and the sum component. Okay, so now we have to arrange it accordingly. Okay, but before that, we must make sure the multiplexer, the input ports is apply okay. Then we must adjust the polarity of the sum parameter, sum block parameter, so positive and negative. And then we can connect the arrows. And then we must double click to drag the arrow from here and to the multiplexer, and then same goes to this part. We must right click the mouse and then bring the arrow towards the multiplexer. We can adjust accordingly. And then there's another connection between the block parameter, the sum block, and also after the transfer function. Okay, and also we need to set the transfer function values. So the numerator value is also the same as the open loop system, 1. Denominator is 1, 1, 1, 6, 11, and 6. Then apply. Okay, so it will change. Okay, and then so as for closed loop system, there's 3 types of controller that we will be using. First is P, second one is PI, and the third one is PID. So in order for us to use those 3 controllers, we must double click the PID controller block, and then we can set what type of controller we want. So let's say we need P controller, then we just choose P controller, and then in using this PID tuner, we can press apply and then tune in order to get the step response. So for example, we press apply and then tune. Then we must wait for MATLAB to generate the graph. Okay, so this is the example on how the graph, the step plot will look like for P controller. So then after that, once we already got the step plot, then you must press update block. Okay, and then so as you can see here, the values just now was, the value for P just now was 0. But after we update the block, the value for P will change, because since we're using P controller, so the value of P will change and we'll get a better step response. And then we must press OK. And then to view the graph at the scope, we must press run and then double click the scope. Okay, so we can see the again, before that, we must make sure the step time is 0, and then apply OK and then run. Okay, so we can see the yellow line, which represents the input. The red line is the step response, and the blue line will be the error. So same goes to the other 2 controllers, which is PI and PID. We just double click the PID controller block, and then we can just change under the controller on which type of controller we're going to use.
Hi, my name is Fahim Azan. My metric number is 882002121. So today I'm going to present about this PID controller, which is assigned for us for group assignments. So as you can see here, this is the components and the equations 1 over s cube plus 6s squared plus 11s plus 6. So this is the transfer function, and then this is the scope. So today, this is the open loop circuit that we are going to demonstrate, and I'm going to run the simulation. Okay, so today we are going to observe the graph that we obtain after we run the simulation. So here, as we can see, the value is 0, fluctuates all over to 0.65, and the value is to the time here until 10. So that would be all from the open loop. Next, I am going to run the simulation for the closed loop. So as we can see right now, this is the simulation for the closed loop. Here, the transfer function is the same, 1 over s cubed plus 6s squared plus 11s plus 6. So this is the scope, and we are going to run the simulation for the closed loop. Okay, here are the values for the closed loop function. As we can see, 0 fluctuates all over to 0.143, I guess. And this is the value of the time, 0 to 4, 6, 8, 10. So that would be all for the open loop and the closed loop simulation.
Hi, my name is Intan Azuna Binti Jamluddin. My metric number is CE2200. I'm excited to present our project progress and achievement, which revolve around the implementations of the open loop system and closed loop system as our model systems. Throughout this task completion progress, we successfully employ the open loop system and closed loop system, which serve as the backbones of our project. To construct the coding circuitry for these systems, we relied on the powerful tools provided by MATLAB and Simulink, leveraging their capabilities to ensure accurate and efficient designs. After constructing our system, the next crucial step was putting them into the test. We conducted comprehensive experiment and meticulously analyzed the result obtained from both the open loop system and closed loop system. This test provided valuable insight into the behavior and performance of our model system. Moving forward, we capitalized on the knowledge gained during our teaching and learning sessions on the topic of PI, and PID controllers. By effectively utilizing this information, we enhance our understanding of control system theory and techniques, enable us to tackle control system problems more effectively. One significant outcome of our project was the examination and summarization of the effect of PID controller on a system. We documented our findings in a comprehensive table that clearly showcased the impact of the PID controller. This table has proven to be an invaluable resource providing guidance on the best approach to control a system throughout the combinations of the study and experimentations. Using the insight gained from the summarized table, we are able to provide position control for the system, effectively achieving the desired target value. This accomplishment enforces the importance of control system theory, technique, and concept in solving real-world problems. In conclusion, our project successfully met its goals, which include explaining and solving control system problems using theoretical foundation, showcasing proficiency in utilizing engineering tools, and highlighting the relevance of classical and modern control systems in current technology for sustainable development. Based on our experience, we recommended that students be given the flexibility to choose from various software options to accomplish similar projects. Additionally, we encourage the inclusion of assignments that involve manual computation, allowing students to enhance their comprehension and abilities in using mathematical knowledge to address control system problems rather than relying on software solutions. Thank you for your attention.